Welcome to Algebra 1, Unit 6, Lesson 6.5. Point Formula, Part 2. Pearson Algebra 1, copyright 2009. I'm Mr. Pilarski, and our objective today is I will be able to write a linear equation from data. Let's jump right into some key words here. Key words in this lesson are going to be rate of change. Now, we talked about rate of change in Lesson 6.1 when on rate of change and slope. The rate of change, we defined it as the change in the dependent variable over the change in the independent variable. Now this is the Greek letter delta, meaning change in, and I abbreviated here, dependent variable and independent variable. So remember, rate of change is the change in the dependent variable over the change in the independent variable. Slope we also talked about in lesson 6.1. And we defined it then as the change in the y's over the change in the x's. And that comes from the idea of the dependent variable always being the y and the independent variable always being the x's. We also have a slope formula, which is y sub 2 minus y sub 1 over x sub 2 minus x sub 1. But for now, remembering that it's the change in y over the change in x is good enough. Point slope form we talked about in the Part 1 version of this lesson 6.5. It's y minus y sub 1 equal to the slope minus or times the quantity x minus x sub 1, where x sub 1 and y sub 1 are the coordinates of an ordered pair. So that's the point slope formula. These words are important, table and data. The data is going to be given to us in the form of a table today. So let's take a look at the point slope formula again real quick. It's the definition of the point slope formula from page 336 of Pearson Algebra 1, copyright 2009. Just as I talked about it before, it is y minus y sub 1 times m minus, or times the quantity x minus x sub 1. That's the second time I said that, but it's m times the quantity x minus x sub 1, close the quantity. We see an example here. Y minus 4 is equal to 2 times the quantity x minus 3, close the quantity. Where in this case the ordered pair is going to be 3 comma 4, and the slope is 2. So we're going to be using this form today. Let's take a look at example 4t, writing an equation using a table. Is there a relationship shown by the data linear? If so, model the data with an equation. So we want to determine if it's linear, and to determine if it's linear, we want to take a look at the rate of change, or the slope in this case, the change in the y's over the change in the x's. That's what we're going to start taking a look at. The slope being the change in the y's over the change in the x's. So we're going to take a look at that change between each pair of consecutive data. Between the first two, the change in the y's from 6 to 4, that's a decrease of 2. I represent that with a negative 2, or a minus 2. And the change in the corresponding x values is a decrease of 1. So the change, or the slope, the rate of change or the slope for the first pair of consecutive data is negative 2 over negative 1. That's the change in the y's over the change in the x's. Now that simplifies to 2. Negative 2 divided by negative 1 is equal to a positive 2. Now between the second pair of data, 4 to a negative 2, the change in the y direction, 4 to a negative 2 is a decrease of 6, and 2 to a negative 1 is a decrease of 3. So the change in the y's over the change in the x's in this case, or the slope, is going to be negative 6 over negative 3, which also simplifies to 2. So far, this data is going to be linear because the slopes are the same. Let's look at the last pair of consecutive data. From negative 2 to negative 6 is a decrease of 4, and from negative 1 to negative 3 is a decrease of 2. So the slope for the last pair of data is negative 4 over negative 2, which of course simplifies to 2. So since all these slopes or the rates of change, or the changes in the y's over the changes in the x's, are the same, this data is linear, so we can model it with an equation. Since we know several points and the slope, we can use the point-slope formula. Which is y minus y sub 1 is equal to the slope m times the quantity x minus x sub 1. We can use any one of these pairs of data as our point in the point-slope form. So if we think of this as an ordered pair, 3 comma 6, we can substitute 6 in for y sub 1. We can substitute 3 in for x sub 1, and we'll use 2 as our slope. So the equation in point-slope form is going to be y minus 6 is equal to 2 times the quantity, x minus 3, close the quantity. So the relationship is linear, and one of the equations that we can use to model it would be this one here. We could have used any one of these 4 pairs of x's and y's as our point for the point-slope form. Example 5t, real-world problem solving. Is the relationship shown by the data linear? If so, model the data with an equation. Here we have the altitude per 1,000 feet, so this 8 really represents 8,000. The temperature here is represented in degrees Fahrenheit. So what we're going to have to do is find the rate of change in this problem. The rate of change is defined as the change in the dependent variable over the change in the independent variable. So here, the temperature is going to be our dependent variable, and the altitude is going to be the independent variable. So finding the change in the dependent variable here between the first pair of consecutive data, we have 197.6 to 203.9. Now, if we, find that out, that's an increase of 6.3 if we would subtract those values to find that difference or that increase. The change in the corresponding altitude values or the independent variables. Remember, let me put this up here. This is the independent variable, and this is the dependent variable. Normally, when data is given in a table, the independent variable comes first, the dependent variable comes second. So the change here is a decrease of 3.5. So we can find that rate of change over here, remembering the change in the dependent variable over the change in the independent variable. So that'd be 6.3 over negative 3.5. And we can just simply divide that out using a calculator, and that would give a negative 1.8. Similar to the last example, this is our slope. This is our rate of change. This is going to be the coefficient for our independent variable. Between the second pair of consecutive data, the change in the dependent variable from 203.9 to 206.6 is an increase of 2.7. And the change in the independent variable from 4.5 to 3 is a decrease of 1.5. So finding the rate of change would be 2.7 over a negative 1.5 using a calculator or by hand. This would give negative 1.8. Between the last pair of consecutive data, from 206.6 to 207.5 is an increase of 0.9, and from 3 to 2.5 is a decrease of 0.5. So that, as the rate of change ratio, would be 0.9 over negative 0.5. And using a calculator or math by hand, you get that as a rate of change of negative 1.8. So since all the rate of change simplify or divide out to the same number, this data is linear, so we can model the data with an equation. Just like we did before, we're going to use the point-slope form. This is the point-slope form of a linear equation. We can use any pair of numbers as our x and our y. The independent variable, remember, is always the x variable. The dependent variable is always the y. So substituting in the equation one of these points as our xy, it's y minus 197.6 is equal to, now our slope in this case is our rate of change, which is negative 1.8 times the quantity x minus this x value, which is 8. Close the quantity. So this would be a linear equation we could use to model this data. Example 6t, using 2 points to write an equation. Write an equation for the line in point-slope form and in standard form. As in the first part of this lesson, we need to write the equation in 2 different forms. In this case, it would be the point-slope form and in standard form. To do this is really a 3-step process, and the first step is whenever you're given 2 points, you need to find the slope. And I made that a t there. It should be S-L-O-P-E, not S-T-O-P-E. And the slope formula is y sub 2 minus y sub 1 all over x sub 2 minus x sub 1. To write this in point-slope form, we need to find the slope, and then we're going to use one of these points. So what we're doing in our first step is finding the slope between these 2 points. As I've done in the past, and I'll do here, I'll label these points x sub 1, y sub 1, x sub 2, y sub 2. That makes substituting into the equation or the formula much easier. So the y sub 2 minus the y sub 1, or in this case 1 minus 4, over x sub 2 minus x sub 1, which in this case is negative 1 minus 1. We simplify that. 1 take away 4 is negative 3. 1 take away 1 is a negative 2. And that double negative does become a positive. So the slope in this case is 3/2. Or 1.5 if you want to work with that. The second step gives us our first answer. Our second step gives us our first answer in point-slope form. We're going to use y minus y sub 1. That's the point-slope form. Equals m times the quantity x minus x sub 1. Now remember, m's our slope. So we're going to pick one of these points, and normally we use the first point. You don't have to, but normally we do. So that'd be y minus y sub 1, which in this problem is 4, times the slope, which we calculated, 3/2, times the quantity x minus x sub 1, which is 1 in this problem. So there's our first answer. That's our first answer right there, the equation in point-slope form. Their answers can vary here because we could have used the other point. Now we're going to start working on our second answer in standard form, and this would be the third step. And the third step is to put the equation into standard form. That's the third step, to put the equation in the standard form. So we're going to take what we just found. We have to take this equation. And you're going to have to, oh, I can't move it, so I'm going to have to rewrite it too. I'm going to take the equation that we just found, y minus 4 is equal to 3/2 times the quantity x minus 1, and I'm going to put that in standard form. Now remember, standard form is ax plus by is equal to c. So I need to make this equation, y minus 4 is equal to 3 halves times the quantity x minus 1, look like this equation. So I got to use some tools from algebra. First, we're going to distribute this 3 halves. When we distribute that 3 halves, that gives us 3 halves x minus 3 halves. I bring down the y minus 4. At this point, I'm going to get rid of this denominator. I'm going to get rid of this denominator of 2 by multiplying both sides by 2. That's using the multiplication property. That's going to get rid of that fraction. Remember, standard form's not allowed to have fractions in it anyway. So I'm going to distribute this 2 on the left-hand side to give me 2y minus 8. And on the left one I distribute the 2, or on the right one I distribute the 2. 2 times 3 halves is going to give me 3. And since it was a minus 3 halves, it'll be a minus 3. And 2 times 3 halves x is going to give me 3x. I really wanted to write this in red. 3x minus 3. So I'm going to write that in red right now. So from here, it's a matter of getting the x and the y terms on the left and the constant terms on the right. So I need to get rid of this 3x on the left, or on the right. I need to move it to the left by subtracting both sides by 3x. 3x's on the right go away, leaving on the right of the equal sign negative 3. And on the left-hand side, negative 3x plus 2y minus 8. I need to get rid of the minus 8 on the left. I need to move it over to the right. And when I do that, or to do that, I add 8 to both sides using the addition property of equality. So on the left, the minus 8 and plus 8 go away, leaving negative 3x plus 2y is equal to 5. And that's because negative 3 plus 8 is 5. This needs to be a positive for it to be in standard form truly. And the way I've taught it in my classes this year is we need to divide both sides by a negative 1. And what that does is change the signs so that our final answer, and I'm going to put that up here, negative 3x divided by a negative 1 is 3x. A positive 2y divided by a negative 1 gives a minus 2y. And a positive 5 divided by a negative 1 gives a negative 5. This by far is probably the hardest example you've done all year, where we've taken 2 points and written the equation in point slope form and in standard form. So here's our one answer, the equation in point slope form, and here's the other answer, the equation in standard form. This has been Mr. Pilarski using the point slope form of a linear equation. Thanks for watching. Bye-bye.